Have you ever looked up at a skyscraper and wondered how it stays standing? Or perhaps you've marveled at the intricate network of bridges connecting cities, defying gravity with apparent ease. The answer to these questions, and countless others, lies in one unassuming yet incredibly powerful structural element, the beam. We see beams everywhere, in buildings, bridges, even our own furniture. But how do these seemingly simple pieces of material possess such extraordinary strength? How do they transform from raw material into the backbone of our modern world? Let's dive in and uncover the secrets of beams. Imagine a beam as a silent guardian, bearing the weight of the world, quite literally. It's more than just a piece of wood or steel, it's a masterpiece of engineering. But what gives it this incredible ability? The secret lies in its shape. A beam is typically longer than it is wide or thick, giving it a specific geometric advantage. This shape, combined with the material it's made from, allows it to resist bending and breaking under immense pressure. It's like the difference between a flat sheet of paper and a rolled-up paper tube. The tube is much stronger, right? But it's not just about the shape. The material also plays a crucial role. Steel, for instance, is renowned for its tensile strength. It can resist being pulled apart. Concrete, on the other hand, is exceptional at compression. It can withstand being squeezed. Often, beams are made of a combination of these materials, taking advantage of their unique properties. Reinforced concrete, for example, combines the compressive strength of concrete with the tensile strength of steel rebars, creating a formidable alliance. Now, let's talk about the different types of beams. There's the humble cantilever beam, which extends horizontally from a fixed support without additional support beneath it. Think of a diving board. Then there's the simply supported beam, resting on two supports at its ends. Your bookshelf is probably a good example of this. And let's not forget the continuous beam, which rests on more than two supports. These are commonly found in bridges and multi-story buildings. But how do engineers determine the size and shape of a beam for a particular structure? It's a complex interplay of factors, including the load the beam will carry, the span it needs to cover, and the materials available. Engineers use sophisticated calculations and computer simulations to optimize beam design. Beyond their structural role, beams also contribute to the aesthetic appeal of buildings. From the exposed steel beams in industrial lofts to the ornate wooden beams in traditional houses, they add character and charm. So, the next time you look at a building, a bridge, or even your own bookshelf, take a moment to appreciate the unsung hero holding it all together, the beam. It's a testament to human ingenuity and engineering brilliance. With that said, thanks for watching, and until next time.